Look, it's drying and the printing in the same time. Welcome to my tech farm. In this video I am testing AMS Heater by SUNLU, and I got this box for free in exchange for the review. There is no additional payment, but this video and the whole channel is sponsored by Polymaker and by my Patreon supporters. This is BambuLab P1P, and this is the first generation AMS, and there are many units out there. And now we have the AMS 2 Pro. And biggest advantage of this new unit is that it is able to dry the filament too. Now it can dry only before the printing, and even we have to disconnect the filament during the drying. It cannot dry during the printing. And now with this unit it is completely independent from this whole system, and we can dry even during the printing. But with this we have to be very careful. The BambuLab disconnected this drying during the printing to reduce the human error. Let's say if we set the drying temperature to 55 degrees Celsius and we want to print with the PLA, 80% of the PLAs I tested will become very soft on this temperature, and it may stuck inside the gear extruder of this AMS unit. PLA don't even dry, maybe a little bit before the printing. PETG, TPU, nylon can benefit from this, but follow those instructions given by the SUNLU. About the nylon, the real drying time for the nylon will take days. That's right. On 70 degrees Celsius. I tested this. Now let's say we dry it only 12 hours and we start with the printing. Now the drying will be always best on the outer loops. So if we dry it only 12 hours, but if we continue to drying during the printing, we can really benefit from this, and we will have much nicer print quality even with those longer printings. Few specifications from the website. It has a PTC heater with a maximal power of 390 watts. It can reach 70 degrees Celsius in only 20 minutes. And after the drying, it can automatically keep that relative humidity low between some set temperatures. And it is very easy to install. And it will work completely independent from the printer and from the AMS. So it is not affected by firmware update or something like that. It will only replace this top cover on the AMS with the 4 screws. And it is completely reversible in case we don't want to use it anymore. But as I mentioned, it has its own control, own power, and it is completely independent from the printer. Let's see what's in the box. This is content of the package: user manual, power cable, screws and hinges, and the main unit. Ventilation holes, there is a screen, more about it later. On the back side, plug for the power cable and the switch. And this is how it looks like from inside. It is upside down now. There's the temperature and humidity sensor, fans, PCB, and the heater is probably inside. And it will go here, replacing this plastic part. Let's start with the installation. First I have to remove the top cover from the old AMS. There are 2 screws on each side. Installing new hinges, and we have some spare parts too. Quick test. Fantastic. That was very fast installation. One nice advantage, nobody talks about it. Now we have a nice flat surface on the top, so we can temporarily pack on it until we don't want to open it. I already mentioned it is completely independent from the printer. Let's turn it on and then I will explain the screen. Using the screen is very simple because we have here the set value, current value. This is the relative humidity, time, and then we have the preset values currently for the PLA. This is the preset value for the PETG, TPU, ABS, PA nylon, polycarbonate. In this mode it will try to keep some preset relative humidity range. Finally it is quiet. It turned off completely only after 5 minutes. This is typical for these PTC heaters, that they don't turn off immediately, only after some time, because they want to cool down inside, and only then to turn off the fan too. Now I'll do my regular sponge drying test, which I usually do with these filament dryers. And what is more important, that during this 1 hour, I will measure the temperature and relative humidity with my own sensors. I'm missing some kind of handle so I can open it with one hand. And during the test I will insert these two nylon filaments, which I know they can survive this temperature. This will be the position of the sponge, approximately in the center of the spool, and that's my temperature and relative humidity sensor. Not the perfect position, but I'm using these ventilation holes. Their sensor is here, but the air circulates inside, so more or less you will get accurate data. I'm collecting the data with Arduino Uno. The current temperature and humidity I can see on this display, but it is also collected every 10 seconds on my laptop. Weight of empty sponge 0.564 grams. And I'm adding 2 milliliters of water, but I'm measuring the weight, it's more accurate. .593. PA nylon. Start temperature was 25 degrees Celsius and approximately 45% relative humidity. But I'm also collecting the data. According to their own sensor, the temperature inside reached 70 degrees Celsius in approximately 13 minutes. According to mine, 68.4, close enough. Soon it will be time for the half-hour measuring, and the temperature stabilized around 70 degrees Celsius, relative humidity 28%, and these are very similar values which I read on my own sensor. It's time for the half-hour measuring. 0.762. One hour passed, and interesting, I can see a lot of moisture here inside the AMS. But this looks completely dry. 0.554. Even drier than at the beginning. It's turned off, only it needs time to turn off the fan too. I will collect some cooling data. Now the moisture is quite big, and maybe you can see here that moisture inside the AMS unit, because these holes are partly closed to hold the cable. But I will open it now to let out this moisture here. Let's check it under the thermal camera. This is the right side, front side, and the left side, and you can see part of the top side too, and from the back side. So basically on the back side only the surface is almost 60 degrees Celsius, and this is from the inside. We can see very constant 70 degrees Celsius air. And also I checked the temperature of the filament. After 20 minutes I took it out, and I could measure the temperature between 56 and 64 degrees Celsius, which is, let's say, quite constant. But I'm missing the rotating of the spool. Let's analyze the graph. On horizontal axis we can see the time in minutes. On vertical axis we can see relative humidity and the temperature. We can see it reached the maximal temperature in 13 minutes according to its own sensor. Then we can see these waves. This is turning on and off the heater every 2 minutes approximately, which is fine. Here it was open for 30-minute measuring, and here for 1 hour measuring it was turned off, and here even the lid was opened. Now let's analyze the relative humidity. It drops when the temperature increases, and it reached its maximal here, the temperature, and it started to pushing out the water from the sponge, and we can see increasing of the relative humidity. Here I let out quite a lot of moisture when I opened for 30-minute measuring, and then more or less it became constant, but quite high. Now it is partly my mistake, because I used those ventilation holes to enter the wires for the sensor, and they were even locked with that opening, so it was maybe open 20%. And with the filament drying we don't have so big amount of the moisture, so this is not a real issue of this dryer, and it is quite constant. And here it was open for the 1 hour measuring, and when I opened the lid I let out quite a lot of moisture. On the sponge drying test we can see that after half hours it removed 90% of the water from the sponge, and after 1 hour actually it removed even more than the beginning, because it has some moisture in it, and these numbers are more or less very typical for these 70 degrees Celsius dryers. It is nice to see a drying solutions for the first generation AMS units too, and this one is quite accurate and gives those 70 degrees Celsius quite accurately. Even the heating of the spool is more or less very equal. Don't forget here we have the heating from the top and we don't have that natural circulation of the air, unlike with those dryers where we have the heating from the bottom. Here we have to rely on the fan for that circulation, but it is quite good and accurate. Of course, I'm still missing the rotating of the spool during the drying, but we can have that rotating if we dry during the printing too, because the filament will unroll. Only pay attention to those drying temperatures, because if you go a little bit higher, the filament may be soft and it will stuck inside the gears of the AMS unit. Okay, this is my experience with the AMS heater by SUNLU. If you have some other, then write me a few lines down in the comment section, and I'm curious, do you even dry the filament? Thank you for watching this video until the end, and happy printing!